This is my all of iGCSE 0580 maths video going through every topic and the things that you need to know. Pre-knowledge, check out the video above. These things I will not go through in this video. I will assume this is pre-knowledge for the course. Timer starts now. Recurring decimals to fractions. So things like 0.333333. And the way we find this out as a fraction, we make it equal to something. So x, for example. Then we multiply by 10. This gives us 3.333. We take one away from the other, so we get 9x is equal to 3. And therefore we can solve this as a normal equation. 3 over 9 equals 1 over 3. Where it gets a bit trickier, say we have something like 0.166666. We use the same method, 166666. We times by 10, like we did before. So we get the recurring bit on its own. And then we have 100x, so times again by 10, that gives me 16.66666. So I take one away from the other, that then gives me 90x equals 15, therefore x is 15 over 90, which simplifies to 1 over 6. Percentage calculations. So the first thing you need to be able to do here is work out, for example, 20% of a number, say 70. So you need to know how many 20s go into 100. Well, that's 5. So we need to divide this number here by 5 to give us our answer, which in this case is 14. This works for lots of things. If you have 15%, then one of the easier ways of doing this without a calculator is to work out 10%, then work out 5%. So that gives us 7 and 3.5, and then just add them together to get 10.5. You need to know what a multiplier is. So a multiplier is what you increase by, essentially. So if I want to increase by 5%, that's the same as 100% plus 5%, 105%, and as a decimal, that's 1.05. Now this is particularly useful for questions on compound interest. This is a formula you just need to learn, which I write as final value is present value multiplied by the multiplier raised to the number of years. So for example, if I have $200 and we have 5% interest and it's over 5 years, to work out the final value, we need to do 200 times 1.05 to the power of 5. Some questions you have to work backwards as well. Ratio, so ratio is just something like 2 to 3, where we have 2 parts here and 3 parts here. So we have 5 parts in total. So we're splitting something into particular parts. Common question is split 60 euros in the ratio of, say, 2 to 4. The way we do this, 3-step procedure, 2 plus 4 is 6. And then we do 60 divided by 6, which is 10. And then we do 10 times 2, 10 times 4. That gives us 20 euros and 40 euros. So I've split the 60 euros into its parts here as well. Sometimes I'll get you to do a problem-solving question. So for example, you have the ratio 3 to 5, for example. You know this side is going to be 70 euros, and you have to work out this one. Again, all we do is work backwards here. So we work out, okay, this is divided by 14. So this would also have to be divided by 14, but we're working the other way. So we're going times by 14, and that will give us 42 euros. Standard form. So standard form is something written as a times 10 to the power of n, where this number is between 1 and 10. And we have this number here can be positive or negative, used for writing very big numbers and very small numbers. So for example, 7 times 10 to the power of 3 is standard form. If I wrote this out, this is the same as 7 times 1,000, which is 7,000. And you need to be able to convert in both directions. So going from normal number, standard form, to normal number. If I do something with a negative, so 6 times 10 to the power of minus 5, the way I do this is I start with my 6. I've got my decimal point here, and I go 5 places then to the left. 1, 2, 3, 4, 5. 0 here, 0's in the gaps, and then it gives me my answer in standard form. One thing they could ask you to do is multiply. So 4 times 10 to the power of 3 times 3 times 10 squared. You just multiply the normal numbers, so that's 12. Multiply the indices, that's 10 to the power of 5. This is not standard form, remember, between 1 and 10. So we need to do 1.2 here, divide by 10, and whatever we do to one side, we need to cancel it with the other. So we get 10 to the power of 6. Sometimes they can ask you this kind of question where you're adding with standard form. The general trick here is to make the base the same. So you want to make this the same or this the same. So you have different choices here. I'm going to make this the same. So we can do 10 to the power of 3, 0.3 times this by 10 and divide this by 10. And the reason is now this is the same. We can just add together and get 4.3 times 10 to the power of 3. Set notation. So this is with Venn diagrams usually. So you have a diagram like this, and you need to be familiar with this. The bit in the middle, so we call this A and B. This is the intersection, so A and B. This can be thought of as and. Okay, if we take this part that I'm shading in here, so everything here, this is known as the union, so A union B, also thought about as or. If it's outside, then it's just not B. So again, you just need to know which parts of this. Again, there's lots of problem solving. I'm not going to go too much detail in this video. Check out the one above because there's lots of diagrams you need to be familiar with. Indices. So indices, remember your index laws. So the most important are 7 to the power of 4 times 7 to the power of 3. That's equal to 7 to the power of 7. You add them. If you have a division here, then you minus them, so 10 to the power of 1. If we have brackets in any case, so 7 squared all cubed, then we multiply them, that's 7 to the power of 6. If we have 25 to the power of a half, so any fraction is some kind of root. This is a square root, so that's equal to 5. If we have 64 to the power of a third, again, some kind of root. In this case, we have a 3, so we have the cube root of 64, and that's equal to 4. If we have a negative index, then it's 7 to the power of minus 2. It's always a fraction, so 1 over 7 squared, and that's equal to 1 over 49. They could mix all these things together. Upper and lower bounds, so say you've got a number 70, and we're, say 70 centimeters, and we're rounding to nearest centimeter, and our lower bound is 69.5, the upper bound is 75, so we call this UB upper bound, this is lower bound. You may think this 5, okay, this always rounds up, this always rounds up as well, but this is the bound. So if we think of this, you can use these inequality symbols to represent that we're not including 70.5, but everything below it, where we are including the 69.5 as well. They could ask you some question like this, for example, where this is 7, this is 4, again, rounded to the nearest centimeter, and they ask for the upper bound, in which case you take the upper bound of both. So you do 7.5 times 4.5, and use your calculator to do the rest. Basic algebra, so if we are adding like terms, so we've got 7x plus 7x squared minus 3x, we only collect up the things that look the same, so these look the same here, so we can collect up to give us 4x, but we leave the 7x squared alone, so that's very important to do here. Linear equations, essentially it's something of this form, so we have an x, a number, and then maybe another number, and the way we do this is reverse processes, so the opposite of minus 4 is plus 4, so we add 4 on both sides, that cancels, giving us 7x equals 11, 7 times something is 11, opposite of timesing is dividing, and we can always leave our answer as a fraction. Again, we could also change this to an improper fraction, a mixed number, sorry, so it's 1 and 4 over 7. That also works. Again, be familiar when you have x's on both sides, so something like this, for example, in which case you minus 2x from both sides first, and then we solve in the normal way, and that will then give us x is equal to 8. Simultaneous equations, they can be written in a couple of different forms. One, for example, would be like this, so we call this 42, and we call this x plus y equals 36. We generally do these by elimination. So how do we do this? Well, we minus one equation from the other. 2x minus x is x, y minus y is 0, 42 minus 36 is equal to 6. We're not finished, we need to work out y, so we sub x into an equation. Let's just put it in this one, makes no difference. So we have 6 plus y is 36, and then y is equal to 30. However, sometimes you have to do these things by substitution, so you might get something like y equals x plus 5, and then you have a sort of standard equation, 2x plus 2y is equal to 10. This is what's called substitution method. Because y is equal to this, we can replace the y with this, so we get 2x plus 2 lots of x plus 5 is equal to 10, and then we solve like a normal linear equation. So 2x plus 2x plus 5 is equal to 10. 4x is 5. X is 5 over 4. And again, don't forget to substitute in to work out the y value. So you have 5 over 4 plus 5, which is 6 1/4. Two methods, again, will also apply to quadratics later. Rearranging formulae, so you can have any formula with lots of different letters, like this, for example, and we have to make one letter equal that. So, for example, if I want to make C the subject, or want to rearrange to make C the subject here, then all I do is make C on its own. So I minus A, so B minus C equals D minus E minus A, and now I can times by C, leaving it in brackets, and then divide through by this bracket. That gives me then C on its own. Whenever you see rearranging formulae, all you need to do is get whatever that letter is on its own. Quadratics, so quadratics are in the form ax squared plus bx plus c is equal to 0, where we have numbers for a, b, and c. There are a couple of ways of solving. The easiest way, if possible, is factorizing. So if we have something like x squared minus x minus 6 is 0. To put this in brackets, we say to ourselves, something that multiplies to give me minus 6, but something that adds to give me 1. In this case, this will be minus 3 and plus 2. Notice x is at the start because we need an x squared, and therefore these two things multiply to give me 0. So therefore we can use 3 dots. X minus 3 is 0, or x plus 2 is 0. X minus 3 is 0, x is equal to 3. X plus 2 is 0, x is equal to minus 2. Notice majority of quadratics have two answers. The alternative is to use quadratic formula, which is x equals minus b plus minus the square root of b squared minus 4ac over 2a. We can use this as well. The a would be the number in front of the x squared, that's this. Here, the minus 1 would be my b, and then the minus 6 here would be my c, and then we just substitute in. We've also got completing the square, so if I use the same example as before to complete the square, so we take half of the middle term, so that's going to be minus a half. We imagine what it is when we multiply this out, that gives me a quarter, so we do minus a quarter, minus 6 equals 0, and then we solve in the normal way that we did in the previous example, so x minus a half all squared equals 6 1/4. We square root, that gives us the square root plus minus of 6 1/4, and then we add on a half. Okay, algebraic fractions. So this could be something like x over x minus 2 plus 5 over x minus 3. When the denominators here are generally things with algebra, you can use the same fraction techniques as you've seen before. So we can just multiply the two things together, and then to work out the numerator, we can then just cross multiply. So we get x times x minus 3, and then we get 5x minus 2. That gives us then x squared minus 3x plus 5x minus 10. We can leave the bottom as brackets. I put 3 dots to speed things up. So we get x squared plus 2x minus 10 over x minus 2, x minus 3. It could expect you to divide fractions. So we had something like this, for example. Then notice we have keep, switch, flip. So we can write this as 1 over x minus 2 times x minus 2 over 4. Notice we have these top and bottom, so we can just cancel through directly, and that gives us a quarter. Okay, inequalities. So this is these symbols, the crocodile symbols. This means less than, this means greater than, this means less than or equal to, so it's this plus equal to, and the other way around works the same way. Again, you approach this like equations. So say we had 7 minus 2x is less than 4. So we approach it in the same way. We minus 7 from both sides. That gives us minus 2x is less than minus 3. However, if we divide here by a negative, which is what we're going to do here, then this cancels. But we have to flip this. This is really important. So we get greater than then 3 over 2. There is something called linear programming. Check out the video above. Sequences, so this is when we just have numbers in order here. So 4, 7, 10, 13, 16. So we have to find the difference. So with linear sequences, we have the same difference each time. To work out the nth term, we take the difference, we put an n next to it, and what do we do to 3 to get to 4? Well, we add on 1. This also works for subtracting. A more complicated one here is when we get something with different differences each time. So we get 2, 8, 18, 32, etc. Notice the difference here. This is plus 6, this is plus 10, this is plus 14. We have a second difference, so plus 4, plus 4. This means we're going to have a quadratic nth term, so something with n squared in. The way that we deal with this is we take the 4, divide by 2. This is equal to 2. So we need to write out the 2n squared. So all the square numbers multiplied by 2. So 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. Actually, we get the same sequence. So our nth term here is just 2n squared. Direct inverse proportion. So this is when you have the fish symbol. So something that looks like this. So y in this case is directly. So this is direct proportion. And we can write this as an equation. We can write this as y equals kx. If it's inversely proportional, so it's got 1 over, this is what's known as inverse, then we can write this then as this equation, y equals k over x, and we can get mixtures of these things. So we have y is proportional to 1 over x cubed, in which case we'd write this equation as y equals k over x cubed. So you need to know these formulae, and also to solve these kinds of problems, you're told one of these relationships, you write this equation, you're usually told x is something, y is say 3, so we put this in, so we get 3 equals 6k, so k is a half, and then we have the formula y equals a half x to then use in the rest of the question. Functions, so this is where this f of x notation, so you've seen this before. Again, this is kind of equivalent to y here. It could be any old function, so x squared minus x minus 6. You need to know how to substitute in, so if they ask you for f of 2, you just replace the x's with 2, so 2 squared minus 2 minus 6, and that will give us minus 4. If they ask you to work out f of x, so a composite function, then wherever we see a x, we put the initial function. So in this one, we replace the entire x with the function, and then with this x, we replace it with the entire function. So a bit Inception-like, and then we just expand out the brackets. To work out the inverse of a function, so let's take a different function here. Let's take an easier function. So g of x equals x squared minus 1. The way we find g inverse, so with the minus 1 here, is we let y equal x squared minus 1. We switch the x's and y's, so x equals y squared minus 1. And then using rearranging, we make y the subject. So that means we get y squared equals x plus 1. And then we just square root, so we get plus minus square root of x plus 1. Generally, we ignore the minus solution here. Okay, I've had a shave. Let's carry on. So, travel graphs. We have distance time graphs and speed time graphs. Graph that looks or something like this. Very important, the area under the graph here is total distance traveled. And the gradient, which I'll talk about in a different part of the video, so the rise over run here. So the steepness, the gradient here is equal to the speed. A speed time graph is slightly different, so we have something that looks like this. In this case, the gradient that was the speed last time is equal to the acceleration instead. Differentiation, so we have a random function, so x cubed minus x squared, for example, to differentiate, which is dy over dx. All we do is take the 3, we bring it to the back, and reduce the power by 1, so that's 2. We do the same here, take the power, bring it to the back, and then reduce the power by 1. To find any turning points, so that's a min or a maximum generally speaking, we take our 3x squared minus 2x, that's a minus not a plus, and make it equal to 0 using our quadratic methods from before. So we can factorize in this case, and this gives us then x is 0 or x is minus 2 over 3, but they may ask you to work out the y coordinate by substituting the minus 2/3 back in. This allows us to find for any curve the gradient at a particular point. Coordinate geometry, so here we've got a straight line. This is the y-intercept, so where it crosses the y-axis, and this 2 and 1, we work out the gradient, so the steepness of a line, by doing what's called rise over run. So in this case, the 2 divided by the 1, and that's equal to 2. And now we can write this as an equation. Y equals, the gradient is 2, so we put 2x. The y-intercept is 1, we put plus 1. If we have another line that's at a right angle to this particular line here, then we know the gradient has to be the negative reciprocal. What is that? We take the 2, we flip it, so we get 1 over 2 and change the sign to a minus. So we know it's got the gradient of -1/2 if there is a right angle in between. Angle symmetry, so the most important part is angles in parallel lines. So notice I've got these arrows here, it means they are parallel. It means that this angle and this angle, so let's call this A and B, these two angles are interior angles and add up to 180. If we take A and C here, this is what's known as a Z or alternate angle, so A equals B, but you need to use these words, interior, alternate, and then finally, if we have A, and this was C for example, and this angle down here was D and D, these are known as corresponding angles. You have to use these words, very important. I'm taking 5 seconds just to say it. If we have a regular polygon down here, the easiest way of working out angles in a regular polygon is we take the exterior angle and then we do 360 divided by the number of sides. This is 6, so this gives us 60. So I can work out this is 60. Angles on a straight line add up to 180, so this has to be 120. When it's not so regular, so we've got a 1, 2, 3, 4, 5-sided shape, so we've got a pentagon of some kind, we can work out the total angles inside by splitting into triangles. I split into 3 triangles, so the sum of interior, so all the angles in the middle, added together is just 180, 3 triangles times 3, and that's equal to 540 degrees. Similarity, so similarity also works with parallel lines here. Notice that these two angles here are the same. This is because they are vertically opposite. We can use what we did in the last slide to say that this angle, so let's call this A and B, are equal because of alternate angles. And we can do the same with the angles to the opposite, so C and D, these are also the same. If all the angles are the same in the triangle, then it is a similar triangle, which means if you've got a triangle like this, which has got a side of 5, and it's similar, and this is 10, and we don't know what this is, say it's 4, then we can just double both sides, and that gives us 8 here. Circle theorems, again, a lot to go through here, but these are the main facts that you need to know. So read them through nice and carefully, and they can test you on any 5 of these or a mixture of them. Unit conversions, so knowing, for example, that 1 meter is equal to 100 centimeters, knowing 1 kilogram is equal to 1,000 grams. However, we have to be careful with these units, particularly when we have 1 square meter, because that's the same as 100 times 100. Imagine you have a square meter, 1 times 1, well, 1 meter is 100 centimeters, so then 1 square meter is going to be then equal to 10,000 square meters. So you have to be careful with area units and volume units too. Area 2D, volume and 3D shapes. These are the extra formula you really do need to know for a cylinder, for a cone, a pyramid as well, volumes and the curved surface area. This L, by the way, which is what a lot of students forget, if we draw a cone, this side is L. It's the slanted side going down here. Sine and cosine rule, these are the rules on here. So we have to use these rules to work out missing sides and angles. So say I've got a triangle, it looks like this, and I have the angle of 70 degrees here. I have this side of 4 centimeters, this is 5 centimeters, and I want to work out this angle. Again, I have to recognize which sides and angles I have. I have a side and opposite angle, so I want to use the sine rule. I make the thing I don't know A, so I get A. So A is the angle, so 5 over sine A is equal to 4 over sine 70, and now I can use cross multiplication to give me then sine A is equal to 5 sine 70 over 4, but don't forget to work out A on its own, you need to do sine inverse. Trig equations, so this could be something like cos x is equal to 1/2. Again, we can use our calculator to work out one solution by using the calculating inverse function. That's going to give us 60 degrees. However, if we think about what the cosine graph looks like, so this is where the graph knowledge is very important, we have to think about, okay, where will the other one be? So this is 60, but we've also got an angle over here. These two lengths are the same. So we essentially need to do 360 minus 60 to give us 300. So you need to know your cosine graph, which is this, going through at 90, 270, and 180, and also the sine graph, which is similar. So it goes something like this, between 1 and -1, and this is at 90, this is at 180, 270 and 360. Okay, transformations, so you have reflections, translations, rotations, and enlargements. These are all the facts that you need to know for those particular transformations. Again, want more information on this, very hard to do in a very short video, then check out the video above. Vectors, so all a vector is it's essentially a line with a direction and magnitude. Okay, so we give it like a little a like this. Again, we can actually work out what the length of this is. Say this is 6 and this is 8. We can use Pythagoras to actually work out the magnitude. This is the key word here, magnitude of the vector. So we can just use Pythagoras. So 6 squared plus 8 squared. And on the calculator, that will just give you 10. So you need to know how to work with that. Also, if you've got a random shape, so say this is vector A and this is vector B, and I want to go from A to C. How do I go from A to C? Well, I take the indirect route A to B and B to C. So A to B, notice notation here, arrows indicating vectors, B to C, and that gives me then A plus B. So these are the main two topics on vectors, working out magnitudes of vectors and working out vector algebra. Probability. That is a very, very big topic, as you can possibly imagine. So, for example, tree diagrams is a very important thing to do. If you've got two events, say this is 0.7 and 0.3, you have to read the question very carefully to see if it's conditional or unconditional. If it's unconditional, the probabilities don't change from one event to another. If they are conditional, they will change for this second step here. If I want to work out the probability of AA, I multiply the fractions together, or decimals in this case, so I get 0.49. If I want to work out the probability of two the same, then I need to take the probability of AA and add to probability of BB. So this is our key rule. So we are along the branches, so this way we're multiplying. If we're going between the branches, we are adding in order to find the solution here. Tree diagrams is probably the most important thing, but I'd also ask you to research this word relative frequency. This comes up a ton on both iGCSE courses. Statistics, and I'm going to focus on one particular part of statistics. If you want more information, check out the video above, and that is cumulative frequency. Again, in real English, as I like to say in class, this is known as a running total. So if they want you to work out 180 how many there are, again, we need to be able to read from the graph like so and read off. Please be careful how you read off. They will be quite mean in terms of the marks they give you, so make sure you understand your scale here carefully. This scale here is in 4, so this is going to be 104. So be very careful as you look through those. Other key topics that you need to be aware of are histograms. So essentially this is a bar chart, but with frequency density. This comes up a ton. Stem and leaf diagrams, which even though is quite easy, this is actually something that appears quite a lot. Again, I've said this in my prediction videos. Again, check out the video above if you're not sure about this. And if I haven't gone into enough detail on any of the topics that I've mentioned, because I've pretty much covered the entire course in this video, then check out the All of iGCSE 0580 Maths playlist, which has about 170 videos at the time of recording that goes through everything you need to know in much more detail.